So okay. So I do this. Okay, that works. Okay. And is there a timer going or? Okay, yeah, thank you. So hello, everyone. I'm Robert Contofalsky. I'm a second-year PhD student at Rutgers University, studying cognitive science under Jacob Feldman. Mainly, our lab just focuses on human perception and human learning. And today, I'm going to talk to you about how we can use constructal law to unite physics and perception through human categorization, and I'll explain all of that as I go along. So just to kind of situate the room, because I don't want to assume anyone's knowledge of the field, psychology is defined as the scientific study of mind and behavior. So it's both things. It's not one or the other. And it has gone through some evolution. In the 20s, it started out as behaviorism. So there's a stimulus in the environment, and then you respond to it, and that's how your mind used to work. But then in the 50s, cognition came about, where they realized that mental processes actually matter, and it's not just the reinforcement of the environment that dictates human behavior and animal behavior. Then in the 80s, there was kind of a shift in the idea that the mind is like a computer, so the inputs generate the outputs, and that's what happens in terms of like the brain and cognition. And that metaphor still exists today, and as we all kind of know, that neural networks and AI have essentially dominated the field. And are still dominating because you can hyper optimize these models with extreme precision in the same way that the human brain does, or works, should I say. But the problem is that you can kind of, like, they're not completely analogous, and they fail to answer the question of how, or not, sorry, they answer sometimes how, but they miss the mark of why the mind works in the way that it does. And I think that now might be the time to enter a kind of like a hard or deep question about how can we add physics into the model of the mind? And I believe that constructal law can actually answer this question. So for starters, as we all know, constructal law is for a finite flow system to persist in time. It must evolve with freedom such that it provides easier and greater access to what flows. And the mind operates in the same way. So Professor Bejan has written extensively about how human mobility follows a constructal pattern. In fact, he spoke about it this morning. However, mobility requires knowing what to move toward and away from, and that's what I want to talk to you about today, which is that cognition is what enables mobility and decision-making through categorization. And to move, organisms must distinguish between food versus poison, safety versus danger, friend versus foe, anything of that nature. Excuse me. So the action of distinguishing kinds is what categorization is. And so if constructal law governs mobility, it must also govern categorization. So essentially, the mobility part is the physical thing that we see in the world, but what I'm trying to get to is that in the mind also operates in the same constraints. So categorization as a groundwork for cognition, that doesn't mean it's the only part of cognition, but it is a substantial component for it. So in short, it can be understood as classifying objects or information as same or different. And essentially, that's an action of doing the right thing with the right kind of thing. So you're distinguishing. So categorization is more of like a flow system in that sense, where this is kind of an agreed upon model. Obviously, the details people disagree about and argue about all the time, but in short, it works in the sense of sensory information comes in, you perceive it, and you categorize it as it is either this or not that, and then you decide what to do with it. And that's the action part, and that kind of creates the feedback loop of how the mind really interprets what's going on in the real world. And it doesn't just it doesn't just apply to the environment. It also goes on into what thoughts and ideas you might have. And so it looks like this feedback loop essentially. And so every category is differential behavior, so you respond differently to food versus poison, safety versus danger. And I argue that categorization is constructal because you're trying to minimize resistance from perception to action. You don't want your interaction with the environment to be laborious. You want it to be efficient. So there's two empirical findings for this resistance minimization. The first one is the simplicity principle, and the second one is expertise. So for starters, the simplicity principle, you might know this as Occam's razor, or in other words, people overwhelmingly prefer simpler explanations to complicated ones. Now, visualizing this is quite hard, but I came up with this example of how to write 5+3 in various programming languages. So the first one up here is machine code. Obviously, if you don't know machine code, this is actually unintelligible. Assembly, slightly less complicated, but still quite abstract. Then you go to C, where it's a bit legible, int a equals 5, but then you go to Python, and it's just 5 plus 3. And as we all know, Python is one of the most adopted languages across the entire world, and this is because, or at least one of the reasons why, is because it is quite simple compared to machine code or other languages. And that is a part of the simplicity principle, where we actually prefer simpler categories to more complicated ones, because this minimizes the resistance that we interact with in the environment. And then this is a slightly less abstract example, but this is the at-neve cat, where essentially, if you wanted to draw a cat, all you have to do is connect 38 points, and you don't have to draw a cat with the fur, the whiskers, the color, etc. But the simple point gets the point across, and that actually saves time and energy when we're interacting with other people. So just to reiterate, the simplicity principle supports constructal law. Humans prefer simpler categories. This is also very well replicated. Machine code to Python is the compression of complexity, and that's what our brain does all the time. We're trying to extract patterns and regularities of the environment and discard redundancy. This can be explained in this room with the colors and the circularity of the tables. A lot of this can be redundant, and we're just trying to see the patterns of how to move across the environment. Simpler is less there's less resistance when things are simpler, and this is a very important part where our brains overwhelmingly prefer this. So it's faster processing with less mental effort, optimizes flow from perception to action. So this is constructal law in short, because the simplicity principle creates two benefits. It provides easier access to flow while also saving energy so we can do other things, and this happens over and over again all day, every day, essentially. So the second piece of evidence is expertise. So this is an X-ray of a pneumatocell, but to anyone who's not a radiologist, this looks like a circle if you were to even see one. If there's no arrow, it would actually be quite hard for many of us. But a radiologist will see this in 2 seconds, essentially, and be able to know or to diagnose this with high accuracy. But a novice, you'd have to train them, you'd have to give them a lot of corrective feedback, and this takes time, but the expert is saving energy and essentially reconfigured this entire image sphere, right? To them, they see this as a diagnostic, but to a person, they might see this as some black and white image, right? So that's one piece of evidence. And then another one is chess. This is very well studied, and especially in the 70s. There's white to move, and there's a mate and 2 here. And an expert might take some time to analyze this, but in comparison to a novice, they would take lots of time with many errors. But the experts do this with rapidity and accuracy. And this is constructal law, where they're having an easier access to flow, and they're gaining even more access to it through their expertise. But this is a cognitive phenomenon that's undergoing itself. So expertise is flow optimization. Novice to expert is a systematic, perceptual, and cognitive reconfiguration of the environment that they're seeing. The X-ray, the circle can mean anything to anyone who's not trained, but to the radiologist, they see this as a very discrete and actionable category to give a diagnostic, essentially. And again, this minimizes resistance to the environment. So faster, radiologists process images in seconds versus novices in minutes or maybe even hours, or maybe in just minutes across many training iterations. And for the chess example, they examine the moves with less moves, and they have higher accuracy than the novices. So again, the same constructal principle as the simplicity principle, where you have easier access to what flow, and you have better outcomes. And these are the 2 key pieces of evidence of how the mind works in a constructal manner. So just to zoom out a little bit, instead of focusing on nitty-gritty details in scientific experiments, there's many historical examples of how these recategorizations of scientific phenomena have changed society. So the first one would be geocentrism to heliocentrism. So just the simple reorganization of celestial mechanics of the Earth at the center to the sun at the center of the solar system gave rise to Newtonian mechanics and other physics principles following afterwards. So essentially, a better categorization by a minor shift in what goes at the center of the solar system gave rise to a greater flow system in the physical sciences. Another one is Mendeleev's periodic table. So he recategorized how to organize elements, and then what came afterwards is a better categorization and study of chemistry. So again, greater access to what flows, and minimizing cognitive resistance. And then Darwin, he revolutionized many things in science, but a lot of that was just straight up biology of like where things come from. Instead of divine invention or divine creation, it's now natural selection that gave rise to many things in biology, but the most linear invention was phylogenetics, and that changed a lot of our understanding of the natural world. And yeah, so each recategorization of the available information reduced cognitive resistance and enabled newer and better discoveries. And this is happening all the time, and our mind is doing this all the time. So why does this matter? Well, constructal law unifies diverse cognitive phenomena in ways that other parts of psychology might not. The simplicity principle, expertise, and categorical/conceptual revolutions are part of this unification. All can be explained by one physical flow law governing flow systems, whereas the other theories might be a bit more disjointed or don't talk to each other, and that can create a lot of confusion in the field. Opens up alternative models to psychology, which was actually quite interesting because psychology is kind of going through a renaissance with the computational revolution that's going on right now. While that is true, computational models have many flaws, with the first one being mainly that humans do not require nearly as much training data as neural networks do to gain the same amount of accuracy, which is a huge flaw in my opinion. Constructal law offers a simple and predictable framework, whereas the computational models can be quite equivocal to a certain extent, and that is a problem in my opinion in the field of cognitive science. And we live in a physical world, so there's no reason that physics does not extend to the mind. This is a slightly more philosophical point of view, but I think it's worthwhile investigating because it opens up new questions, and new questions is what we want to do as scientists all the time. So, in conclusion, human categorization is governed by constructal law. Cognition is a flow system. It evolved to minimize cognitive resistance and maximize behavioral freedom. It is observable from the individual to the societal through the simplicity principle, which is essentially the compression of complexity, expertise, so flow optimization through acquired knowledge, historical recategorization, so societal level evolution, although this is more across through time, and then the physics of life extends to the physics of the mind. Thank you.
Questions? Yes, please.
Thank you. Super interesting. I was wondering how reflexes kind of would fit in with what you've been talking about, and I can see this in kind of two different aspects. Like there are instinctual reflexes that you don't think about, you never even had to learn, but then also through repeated stimulation.
Like a patellar reflex, or just like reaction time?
Big reaction time.
Okay.
So, but then also there are reflexes that you can essentially train through education that become intuitive, and just how to think about those as what you've been talking about.
Can you reframe that question? I'm not sure I understand what you're asking.
Yeah, I guess so. In part, it was at the very beginning you were talking about motion and how it requires having to think about kind of the stimulus, where you're coming from, where you're going, and so in that sense, just like pure, what I'm calling kind of instinctual reflexes, those you don't have to think about. So is that kind of a predecessor that before what you're talking about, or is it just too orthogonal?
It's slightly orthogonal. I mean, psychophysics is definitely a part of cognitive science as a whole. I would imagine that reflexes do follow some type of constructal pattern, but they're a very small subset of what you would study in the lab. But yeah, they can be tracked in time. I don't have the math skills personally to kind of go deeper in that realm. I'm just mainly talking about more broader, like conceptual knowledge, because that's more my expertise. But I'm sure you could, if you had some psychophysics training and better math skills, you could probably find some type of constructal pattern that emerges.
Thank you. Questions?
Yes, nice work. I'd like to maybe make a connection, if you could, with semiotics.
Yep.
And the work of Kahneman.
Semiotics and
Fast and slow.
Oh, Daniel Kahneman, yeah. So I didn't want to talk about heuristics per se, because one, it's not my expertise, and two, it's kind of a different subject. But yeah, heuristics definitely would fall under that constructal principle where basically intuitive models of the world serve your survival and your decision making and your perception. I would definitely say that they fall under the constructal principle for sure. And for everyone who doesn't know what a heuristic is, but it's essentially a heuristic is that you don't necessarily rationally deduce everything in your environment. You just have kind of an automatic reflex of the information. You make a decision based off how you intuitively feel about the environment. It's not necessarily like a hyper-rational model. Does that answer your question?
It's okay.
Okay. We can talk after, yeah.
Question.
I had a question about your compression of complexity. Can you please explain that to me?
Yeah, so it is more difficult to perceive information that is overly complex. And the brain wants to compress the complexity or essentially reduce it, right? So that's why I gave the machine code example where you can write 5 plus 3 and 1, 0, 1, 1, 0, 0. But if the brain wants to find a way to optimize getting to that goal of 5 plus 3, you can invent things like assembly or C to get at the same principle, even though you're using the same computer architecture essentially. Does that answer your question?
Yes and no. I was thinking that complexity is the direction in which everything evolves. So are you inhibit evolution with compressing complexity?
No, this is a cognitive phenomenon, right? So you reducing complexity actually would increase your survivability because your decision making is faster and more optimal, right? So you're just trying to make things as simple as possible, not necessarily as a counter to your evolutionary environment, but mainly to optimize your decision making, right? So the cognitive system doesn't want to be overloaded with or overstimulated with information to the environment that might be irrelevant, because you want to extract the relevant features of the environment in order to navigate it properly. Does that make sense? Okay, awesome.
Thank you. Any other question? Thank you very much.
Awesome. Thank you, guys.
By the way,
Yes.
yeah, your simplicity principle. Bring that to the attention to colleagues of ours who talk about the fact that nature is evolving toward greater and greater complexity.
Okay.
Yeah.
I'll try to make that gap.
Yeah.
Or sorry, bridge that gap.
And try not to smile when you say that. Okay, very nice work.
Thank you, Adrian.
All right, before we break for coffee.